Okay, so like I said, we're going to get started here with 6-5. We're going to talk a little bit more about determinants because we have seen them show up, especially when we just did like the inverse of that 2 by 2. But we're going to talk about how do you find determinants for other size matrices as well. And then we'll also talk about something called Cramer's rule. Cramer's rule is a way for us to solve a system of equations, but it uses a lot of determinants to help us do that. So that's why we're going to kind of spend a little bit more time focusing in on how do you work with a determinant and solve for a determinant. Remember when we did a 2 by 2 matrix like this one, to find the determinant, you just cross, multiply, and you subtract. We just did that on our bell ringer today. So for this, I would just take 10 times 5 minus the 9 times 6. So this would be 50 minus 54. And so that would come out to be -4. That's just how you always evaluate a 2 by 2 determinant of that matrix. Like you're just going to cross, multiply, and subtract. So how can we use this in Cramer's rule? Well, Cramer's rule says that if you have a system of equations, so if you have two equations that have x's and y's, so we're still going back to like a 2 variable system. I'm not dealing with the 3 variable quite yet. I can look at the way that those equations are written and I can kind of separate them out and use determinants to help me solve for the x and for the y on my system of equations. Now, what's written down here is kind of like a general form of Cramer's rule. So there's a lot of letters. There's no numbers like really put in for anything. But what we're going to be looking at, again, are our coefficients. So we should be used to pulling our coefficients from a matrix because we've had to do that before when we were doing our Gauss-Jordan elimination and substitution. So we're going to pull the numbers that are sitting in front of your x's and your y. And then you're also going to work with the constants. Now, the very bottom of both of these looks the same. You're going to take just the numbers in front of the x and the y. That's going to go on the bottom half of the fraction in its own matrix, and you're going to find the determinant of that. The top is what changes a little bit. So on the x side, notice how instead of having the a1 and a2, the numbers in front of the x, they replace those here with the c's. The c's are the numbers at the very end of your equation. So those are going to go in place of the x, and then the coefficients from your y variables are going to just drop down. Something similar happens over here with the y, except instead of the numbers in front of the y coefficients, they're replacing those with the numbers right after the equal signs. Okay, so it takes a little bit of time to kind of get used to that, but it's always going to work this way for when you're solving an x and a y. You're always going to set it up the same way, so nothing is going to change in that sense. So let's take a look at an actual example here. So I'm just going to kind of zoom out so we can still see that setup up above. But so I have this new system here, 5x plus 4y equals 12, 3x minus 6y equals 24. The first thing I'm going to do is just grab my coefficients in front of my x's and y's and put that on the bottom, because that's going to be the same for both of them. So the numbers in front would be 5 and 3, and 4 and -6. And you can see I'm putting those on the bottom here. Now on the top, I have to be a little bit careful here. For the x, I don't want to use the 5 and the 3. I want to replace that with the 12 and the 24. The constants are always going to go in for the coefficients of the letter that you're trying to solve for. So since I'm trying to solve for x, I'm going to put the coefficient numbers 12 and 24 in place of those x coefficients. And then the 4 and the -6 are going to get used again here. What numbers would I need to write over on the other side for the y? What would come first? 5 and 3. And then what goes next?
12 and 24.
Good, 12 and 24. Again, we're replacing the y coefficients with those constants. And now we're going to solve the determinants. We're going to do the top and the bottom separately, so we'll cross, multiply, and subtract for the top numbers and the bottom numbers, and then you're just going to divide at the very end. So for my top numbers here, we're going to take 12 times -6 minus 4 times 24. On the bottom, you're going to take 5 times -6, and you're going to subtract 4 times 3. Okay, and all of this is being divided. So you're going to just have to multiply and subtract, and then we'll get our division sign here. So on the top, when I do this, I think I have written down anyway that I got negative 168 when I cross multiplied and subtracted. And then on the bottom here, this would be a negative 30 minus a 12. So that becomes negative 42. So then we just take negative 168 divided by negative 42. What do we get? 4. So x is 4. Then we're going to do the same thing over on the other side. The bottom is not going to look any different. Okay, so this bottom number is still going to end up being a negative 42 because the bottom determinant for both of our x and our y's is the same. The number on the top is going to change a little bit. You're going to take 5 times 24 minus 12 times 3. What does that number come out to be? 84. So then we're going to take 84 divided by negative 42. So what's your y? Negative 2. And then we're just going to end, I'm going to write as an ordered pair, 4 comma negative 2. There's my answer. That's how Cramer's rule will always work for a 2 by 2 matrix. Okay, so I'm going to give you guys a couple of minutes. If you guys turn the page over, there's a problem for you to try. Okay, so I'm going to give you a couple minutes here. Go ahead and set up your, like all of your determinants there. Do your process that we just did. Try to practice what we just went over. Okay, I've got mine set up here, and I'm starting to do the math. I got for x, it was negative 6 over negative 1, so that comes out to just be a positive 6. And then on the other one, it was negative 7 over negative 1, which is just 7. Did you guys all get that? Or got close to it, maybe? Okay, questions on how we solve a 2-variable system of equations? Okay, so we're going to kind of start getting into the 3 by 3 matrices now. We can still use Cramer's rule for a 3 by 3, but to find the determinant of a 3 by 3, it's not as just clean and cut and dry as a 2 by 2 is. 2 by 2 is really easy because it's just cross, multiply, and subtract. 3 by 3 doesn't quite work that way because even if we tried to cross multiply, we would not be hitting all of the numbers inside of the matrix. So it would be impossible to just kind of follow the same method that we were just using. There's actually two ways that you can find the determinant of a 3 by 3 matrix. And I'm going to go over both of them. The first one is called expansion by minors. And how this one works is that you're going to eliminate the row and the column of the element that you're working with and multiply by the element. Again, they're giving you kind of a big overview idea of what this looks like. Now there's a lot of letters on this first one, okay? But eventually you'd start working with numbers. But what that rule basically says is if I'm taking A, okay, which is what they put first, I would eliminate the row that A is in and the column that A is in. So I would get rid of the DG and the BC. And then what goes into the determinant is what's left, E, H, F, and I. Then I would evaluate this 2 by 2 determinant the same way we were just doing, cross multiply, subtract, but then I would have to multiply by my A term that's in the front. Then I would move on to the B term. So we're basically just focusing on this first row. If I have B, because that's what they wrote second, I would eliminate the E, H, and the A, and the C. And that's where we're getting the D, G, F, I from. So you're eliminating the row and the column from the A, the B, and the C. And then the last one, if we started with C, we would get rid of F, I, and A, B, and you're left with D, G, F, and I. It's a little bit of a pattern to get used to, but if you understand that you're taking the numbers from that first row, or first column, I should say, and you're getting rid of all the other row and elements there that you're left over. Yeah.
So for C, if you're getting rid of F and I.
Oh yeah, it should be EH. That's a typo there. Let's fix that. I don't know why that says that. That should be an E and that should be an H. Thanks for catching that. Are the other ones okay?
Yeah, they should be.
Okay. Yeah, so that last one should say D, G, E, H. So yeah, make sure you change that for yourself. Okay, and then I'm going to actually show you how this works. So if you guys come down right underneath that, I threw in some numbers to our matrix. So the first thing I did is starting with the 1, I got rid of the column and the row. So the 1 comes out front, and then the 5, 8, 6, 9, that goes on the inside. Then I go back and I do it with my 2. So the 2 comes out front. I'm left with then 4, 7, and the 6, 9 after I get rid of my row and column there. And then the last setup is the 3. Again, I'm just getting rid of those elements. So 4, 7, 5, and 8 are what's left over. And then what they're showing you down below is they're just doing the cross multiplication and subtraction. They kind of are doing some of the math already. They're not showing you every single step like explicitly here. But so 5 times 9 is where they got the 45 from. 6 times 8 is 48. And they did that for all of them there. They cross multiplied and subtracted. And then they just kind of slowly start working their way towards the end. What they got for an answer here, though, was 0. Okay, so underneath that, there's another one here. Go ahead and see what you can do with that one. Make sure you're watching your signs too, like in between the operations of the determinant. It's always a minus sign first and then a plus sign. That's just how they're always set up. Slowly working through mine up here. If yours is looking like mine, what'd you get for a final answer?
Negative 24.
Good, negative 24. So there's your determinant. Now, eventually we'll start using these in Cramer's rule as well for a system with 3 variables. Right now we're just practicing finding the determinant. Now, like I said, there's 2 methods. This is only the first method. I'm going to show you another way that you could find the determinant of a 3x3. When you start doing these on your own, and you actually have to like solve an equation, I don't care what method you use. So after I show you the second one, and we get some practice with that, if you prefer this one over what we're going to do on the second one, that's fine. Okay. I like the second method better, so I will probably lean towards that as I'm like going through other problems in the future. But you're always able to come back and do this one if you like it more. The next one is called using diagonals. And so we're going to basically add some numbers to our original matrix and start grouping things up with diagonals, and then using kind of like almost like our cross multiplication idea, but we're not maybe doing 2 x's here. When you have something bigger than a 2x2, like a 3x3, you're going to want to rewrite the first 2 columns besides the matrix. Then you're going to find the product of each diagonal, and then you're going to add the bottom and subtract the top. It might be helpful if you have highlighters or like colored pens or something, because as I'm going through this, I'm going to start circling numbers or maybe highlighting numbers so you can see what needs to go with what. You don't have to do that. You don't have to have fancy highlighters and pens to do this. You can just do it all on a pencil, but I do think sometimes for some students who need help with organization, having these kinds of things helps a little bit. So what they did here on this first one, it's kind of a little bit of a mess here, but they basically took that matrix that we were working with on the previous page. I didn't change the matrix, so we already know what the answer should come out to be here. But they took the first 2 columns, the 1, 2, 3, and the 4, 5, 6, and they rewrote those here. Okay, so that's step 1, is just take those first 2 columns and just write them directly to the right of your original matrix. Then you start to look for your diagonals. Okay, your diagonals are going to be the 1, 5, and the 9. You're going to multiply those numbers together. That's where they're getting this 45 from. Okay, because 1 times 5 times 9 would be 45. Then we're taking 4 times 8 times 3. That's where they get the 96 from. And then the last diagonal going this way is 7, 2, and 6, and that's where they got the 84 from. So you're just multiplying those numbers along your diagonal. Notice in what they did over here is they took these numbers, 45, 96, and 84, and they wrote those up in that first set of parentheses, and they're just adding them together. Now we're going to switch to our other diagonals. So your other diagonals start at the bottom left corner, and they go up toward the right. So 3, 5, 7, if you multiply those, that's where the 105 comes from. 6, 8, and 1 is 48. 9, 2, and 4 is 72. This is why I said sometimes having highlighters or colored pens to circle those numbers can be a little bit helpful, especially if you're one who gets a little bit confused with a lot of numbers like this, or you need some help organizing it. And then again, they took these numbers, so all of these, and they put those down here. So notice how they're adding those products all together, but do be careful because in the middle there's a subtraction sign. So after you add all those products, you then subtract. We got 0. We got 0 on the previous problem too. That very first one I showed you how to do the expansion by minors, that answer came out to be 0. Okay, so this next matrix, this is the exact same matrix that you just did on your own. So we all know the answer should already be negative 24, but I want you to practice using the diagonal method. So start by writing out your first two numbers here, or first two columns, I mean. 4, 2, 3, 5, 3, and 6. Try to do the diagonal method. See if you get that negative 24 again. Okay, I've got mine kind of started to go up here a little bit. I did write out all the multiplication instead of just writing the numbers down below and above the matrix, but you don't have to do that. If you wrote your numbers when you multiplied on your matrix, that's fine. Did you guys still get negative 24? Because this side should be 120 minus 144, so should still come out to be the same thing, but just using a different method. So like I said, going forward, we're going to continue to use these types of matrices in order to help us solve a system with 3 variables, and we'll talk about how to use that with Cramer's rule. I'm probably going to stick more towards the diagonals method because I prefer that. I do think it's a little bit faster than using the other one. Okay, but if you like expansion by minors, you are welcome to use that instead. Any questions on evaluating the determinant those 2 ways? Okay.